So as Salwa mentioned before, we will be talking about CLI spoofing, but before we jump into what that is, I will take a step back and try to understand how things are supposed to work. So I'm just waiting for my slides to share. There's a problem. Oh, okay. So apparently I cannot share my slides, so I will try to share my window instead. I hope that you can see my slides now. Yes, perfect. Okay, so let's start. When you make a phone call, your phone number, that's what's called calling line identification, or CLI. This phone number gets sent along with the call. It's what lets the other person on the other end of this call see who's calling before they pick up. Pretty standard stuff. This system has actually existed since the late 80s, and it plays a big role in how we trust phone calls. It's also what helps services detect spam, prevent fraud, and even trace calls when needed. But what if that caller ID isn't telling the truth? What if someone pretends to be calling from a different number? That's when we enter the world of CLI spoofing. And that's exactly what we are going to explore next. So you are at home, your phone rings, the screen lights up, it's your bank. But on the other end of the line, it is not your bank. It's a fraudster sitting somewhere far away, using a simple trick to make their call look like it's coming from someone you trust. They have changed the caller ID, the CLI, to impersonate your bank. It's not a glitch, it's tactic. It's called CLI spoofing. You see the familiar number and pick up. The fraudster sounds professional, polite, and sometimes very urgent. So they already have your trust because the number on your screen give it to them. With a bit of persuasion, they get what they came for: your passwords, your one-time codes, maybe even some money transfer. So that's CLI spoofing. It's not just a tech wizardry, it's fraud by deception, dressed up as someone you already believe. Now, CLI spoofing is not just used for social engineering scams. It's also a way to cheat the system in the telecom world, specifically to avoid paying international call charges. So here is how it works. Imagine someone makes a call from country A to country B. Normally that call would be treated as international, and each operator along the way would charge a fee. That's called interconnect billing. But some carriers or middlemen, called intermediary providers, finds ways to manipulate the CLI before the call reaches its final destination. So instead of passing the real number, they insert a local-looking number. So when the network in country B gets the call, it thinks, oh, that's a local call, not an international one. So that means that they will get billed as a much lower rate for the call that looks local. Meanwhile, the fraudster will keep the money that should have gone to the legitimate carrier. So this kind of manipulation causes a major revenue loss and breaks the fair system that's supposed to support telecom networks globally. So far, we have seen why fraudsters use CLI spoofing, so for scams or to bypass billing. Now let's look at how they actually do it, starting with spoofing via VoIP, or voice over IP. So how it works. Fraudsters start by using a SAPE softphone app or a custom script. These tools let them manually enter whatever number they want into the from field of the SIP invite message. So that's the part that tells the system who is calling. They don't use their real number. Instead, they type in something that looks trustworthy, maybe a local number or something that appears to be from a bank or a government agency. This message is then sent to a VoIP provider or a SIP tracking service. And here's the problem. If that provider does not check or validate the caller ID, and many of them don't, the fake number just gets passed along, no question asked. So the person receiving the call has no idea. All they see is the spoofed number on their phone screen. As far as they can tell, it looks completely legitimate. And because this whole process can be automated with scripts, attackers can send out thousands of these spoofed calls every single day, quickly, cheaply, and at scale. Now, let's look at another layer of caller ID spoofing. And this one does not involve apps or scripts. Instead, the manipulation happens inside the telecom infrastructure itself. So when phone calls travel between carriers, they use signaling protocols like SS7 or SIP. These protocols carry important call details, including the caller ID. But here is the issue. In both cases, the caller ID is not encrypted or authenticated. So that means that any carrier in the middle, often a transit provider or a gray route provider, can step in and change the caller ID. So they can make an international call look like a local one, right in the signal layer. So the result, the person receiving the call sees a familiar local number, even though it might be coming from the other side of the world. This not only tricks the user, but it also bypasses international billing. So the legitimate carriers lose revenue, and tracking down the real origin of the call become much more difficult. Now that we understand what CLI spoofing is and how it works, let's talk about why it's used. At its core, spoofing is not just about changing a number, it's really about manipulating trust. So the fraudster lies about who they are, hides where the call is coming from, and uses that false identity to trick people into giving up something valuable, usually money or sensitive information. Often they impersonate trusted sources like banks or government offices or even the police. And when you think someone official is calling, it's easy to let your guard down. That's exactly what they want and what they are counting on. One common tactic is voice phishing or vishing. In these calls, the scammer tries to get you to reveal things like passwords, one-time passcodes, or credit card details. Some go even further, running elaborate scams or pretending to be a family member in trouble to create panic and urgency. Spoofing also helps them bypass protections. If someone has blocked them before, or if the carrier is trying to filter scam calls, spoofing a new or local looking number helps them get through. These techniques, known as neighbor spoofing, makes the call seem familiar, so people are more likely to pick up. And finally, spoofing gives them cover. By faking their number, they can hide their real identity and location. This makes it much harder and sometimes impossible to trace the call back to its source. So as you can see, spoofing is a powerful tool for deception, and it plays a central role in many modern scams. Now let's talk about one of the biggest reasons CLI spoofing works: money. Spoofing is not just about tricking people. It's also about creating huge financial gains for the fraudster involved. And it all comes down to the difference between international and national termination rates. On this first slide, you can see how a legitimate international call works. The call starts with operator A, travel through a chain of international carriers, and finally lands with operator B in the destination country. Each carrier along the way takes a small fee, and at the end, operator B charges a high international termination rate, in this case 70 cents per call. That's all standard. It's regulated, and most importantly, it's transparent and traceable. But now look at this second slide. This is where fraud creeps in. Complicit carrier steps in and spoofs the caller ID to make the call look like it's coming from a local number. Because of that, operator B thinks it's just a regular domestic call and only charges the local rate, 7 cents. So what happens for the rest of the money? The fraudster, the one who manipulated the CLI, keeps the difference. So they collected the international fee, only paid for domestic delivery, and walked away with 600% profit. And they can do this across thousands or even millions of calls. Meanwhile, operator B loses revenue, and the regulator loses out too, because call volumes and termination fees are misreported or not reported at all. And this isn't just a rare loophole, it's widespread cross-border form of fraud that takes advantage of weak trust in caller ID and lack transparency in call routing. So at this point, you might be thinking, wait, is CLI spoofing always illegal? And the answer is absolutely not. In fact, there are many perfectly legitimate and ethical uses of CLI spoofing when it's done transparently and with the right intentions. Take call centers, for example. They often use one main recognizable number for all outgoing calls. This helps with brand consistency, so customers always know who's calling, instead of seeing a different number every time. The same goes for large businesses. They might have different departments or branches, but they present a single unified contact number. That's not about deception. It's about keeping things clear and professional for the customer. Marketing and survey agencies use CLI spoofing too. So instead of showing constantly changing numbers, they display one business line that people can recognize and call back if needed. It improves response rates and helps with tracking. And beyond commercial uses, there are important cases in law enforcement and national security. Investigators, for instance, might need to use spoofed numbers during sensitive operations to avoid tipping off a suspect or to make sure a call isn't ignored. So the key point here is it's not the technology that's bad, it's how it's used. Once the CLI spoofing is used to improve communication and build trust, it's legal and even beneficial. It only becomes a problem when it's used to deceive, defraud, or bypass regulations. CLI spoofing is not just a technical annoyance or a clever trick. It's a multi-billion-dollar problem that affects nearly every part of the telecommunication ecosystem. So let's break down who is impacted by this and how. First, telecom operators. For them, the biggest issue is revenue leakage. When fraudsters manipulate call routing, operators lose out on international termination fees. That's money gone. And on top of that there is regulatory penalties, reputational damage, and rising fraud detection costs just to keep up. Now consider the regulators. They are not immune to the impact. In many countries, taxes and fees are tied to how calls are classified or where they originate. So when spoofing alters that data, government lose revenue too. And beyond the financial side, regulators face public pressure and the heavy of trying to track, trace, and shut down these schemas. But let's not forget the most important stakeholder, the customer, the real people receiving these calls. So for them, spoofing leads to financial scams, privacy violations, and a deep loss of trust in their phone provider, in their bank, and sometimes in their own instincts. So the emotional toll can be just as damaging as the monetary loss. Imagine thinking your bank is calling, only to realize you have been tricked into giving away sensitive information. There are also serious security implications. Spoofing makes it difficult to trace calls, which can disrupt law enforcement investigation and even pose national security risks. So, according to the Communication Fraud Control Association, or CFCA, global losses from voice interconnect bypass, which includes CLI spoofing, hit over $5 billion in 2023. That makes it one of the top 5 telecom fraud types worldwide.
So I think now, before we move on to tools and technique used to detect and block CLI spoofing with Selwa, we'd like to take a quick moment to hear from you. So we're going to launch a short interactive poll with 5 questions. This will help us better understand how fraud monitoring is currently approached across different organizations, either it's operators or regulators. Each question we're gonna share will stay open for about 1 minute, so feel free to answer honestly, because your responses will remain anonymous. Now I'm gonna share the next question. And now we're gonna share our last question. Now Selma will continue the session. Yes, so.
So now we will tackle the most used tool or important used tool to fight back against CLI spoofing. We will start with the most used one, and that's the stir shaken framework. It's already widely used in places like the US and Canada, and it's become the standard for securing caller identity in modern networks. So let's break down what it actually means. STIR stands for Secure Telephone Identity Revisited, and SHAKEN stands for Signature-Based Handling of Asserted Information Using Tokens. It sounds complex, but you can think of it like a digital passport system for phone calls. Here's how it works. When someone makes a call, usually through a VoIP provider, that provider attaches a digital signature to the call. This signature confirms that the caller is authorized to use the number they are presenting. As the call travels through the network, the receiving provider checks that digital signature. If everything matches up, the call is treated as legitimate, and in some cases, it might even show a verified caller label on the recipient's screen. Sorry. It's a big step forward in rebuilding trust in phone calls. But like any system, it has its limitation. As noted in the top corner of this slide, stir shaken only works for VoIP or state-based networks. So it doesn't protect calls on legacy systems like traditional landlines. And its effectiveness drops across international borders where not all carriers have adapted this framework. So while this is a powerful tool, it's not a silver bullet. It's most effective when it's part of a broader strategy, one that includes regulatory cooperation, caller ID validation, and end-to-end adoption across the telecom ecosystem. So how actually we detect when CLI spoofing or route manipulation is happening? One of the main methods used today is something called test call generation, or sometimes it's referred to as probe testing. How it works? We simulate real calls, just like a normal customer would make from different international locations. As you can see here on the left side of the slide, each of these calls travels through different interconnect paths, but ends up at the same destination operator. Then we compare the results. we'll look at how the caller ID shows up on each call and how the call is classified or handled. This helps us spot problem like CLI refilling or spoofing or fake or incorrect caller ID is inserted somewhere along the route, or bypass fraud, where an international call is disguised as a local one to avoid higher fees. So this is a very powerful detection tool, but there is a catch. This kind of testing is expensive. To do it properly, you need to generate a large volume of calls across different countries using different carriers and at different times of the day. So that requires a lot of infrastructure, coordination, and budget. Because of that, most operators use test call generation selectively, often as part of a broader fraud detection strategy. Um, One of the methods that is at the rise recently is machine learning, because it can analyze a huge amounts of data and find patterns that humans or even a basic system uh, would likely miss. So machine learning can look at things like call pattern analysis, checking for unusual frequencies of a call, strange mixes of destination or odd call durations. It can also check geolocation patterns, for example, spotting numbers that supposedly calling from two different countries at the same time, or temporal analysis, catching unusual behavior like sudden surges in call volume at some specific time at night, or strange traffic spikes from inactive numbers or from some destinations, etc. So all this data can be fed into the machine learning model, which learns how to detect hidden patterns and subtle anomalies, things that might signal spoofing or route manipulation. So what makes machine learning really powerful is that it gets better over time. So there is a feedback loop. Every time the system flags a call as fraud and it's confirmed, that result goes back into the model, which learns from that and adjusts. So the more it sees, the smarter and accurate it becomes. So to wrap things up, let's talk about what we can do as a strategy to tackle CLI spoofing at scale. First, it starts with the caller ID authentication. So frameworks like StairShaken or regional equivalents are essential for verifying that the number you see on your screen is the real one. This is especially important for IP-based network, where most of spoofing happens today. Second, we need advanced fraud detection systems powered by AI and machine learning. These tools can spot patterns and anomalies in real time, catching spoofed or manipulated CLIs that would easily slip past traditional systems. Third, we have to focus on call traceback and route verification. It's not enough to block suspicious calls. We need to trace them back to their true origin and confirm that the routing path has been tampered with. Four, this is a global problem. So we need international regulatory collaboration. Spoofing does not stop at borders. That means we need shared technical standards, aligned policies, and mutual enforcement to make a real impact. And finally, all of this needs to be backed by strong enforcement. That includes meaningful penalties, fines, license suspensions, and blacklisting for repeat offenders. Because without consequences, the fraud continues. So if we can implement a few of these best practices consistently across networks and borders, we'll be in a much better position to restore trust in our communication, protect revenue for operators and government alike, and most importantly, to secure our networks for everyone. So that's end up my speech today, and we will go to the Q&A session. Please feel free to ask questions. Thank you.
Okay, we have some interesting questions. And we're gonna start by the first question, which is related to the technique that are used to detect CLI spoofing. Yeah, yes, there are AI or machine learning technique. There are test call generation, but of course there are other techniques that basically rule-based detection. For example, with the reconciliation between the MSC and the IN CDR, we can detect, for example, if there is any CLI manipulation. But this, it will be easy at the regulator side. For example, let's say that the regulator is collecting the data from telecom operators. They have the outgoing calls in the MSC, and if the operator is manipulating the CLI, it means that the outgoing call will never be charged. So doing a reconciliation between the core network and the charging system can help to detect at scale these kind of manipulation. If the CLI manipulation happen, for example, at the carrier level, like a transitor, before that the call terminate into the operator side, we saw, for example, in the past that some transitor manipulate the CLI, and when operator do reconciliation, especially for interconnection, we raise some what we call it. We don't agree on the reconciliation numbers, and especially for roaming. Sometimes subscribers that are roaming abroad, and when they make outgoing call, there is the signaling that goes through a carrier, or when they call back to the country. So transitor rely or skip behind that there is always roamer outbound traffic that can generate signaling toward home network. But again, with the reconciliation between the core network CDRs and the IN, most of the subscribers are prepaid. If they make outgoing call, even in roaming, or even incoming call, they are charged. So we can detect that the call is a real roamer or not. Sometimes they use also numbers that are not allocated to the carrier by the regulator. So sometimes, yes, with some rules, we can detect this pattern, of course. There is another question that is really related to the same question, which means using a fully machine learning system, or does this kind of system can be used by telecom operator and regulator? Again, yes, it can be used by regulator. It's detecting CLI spoofing is better effective at the regulator side, because the regulator, if they collect all the data of the operators, for example, if a call was initiated by operator A toward operator B, and we suspect that operator A is manipulating CLI. Okay. Sometimes operator B does not have enough evidence that is a CLI spoofing, because operator A can manipulate the CLI using real allocated numbers that are not used by our subscriber. So again, operator B, it's very hard to detect this kind of CLI spoofing. But at the regulator side, if they have traffic from both operator, we can verify that CDR, for example, from the operator A, is it charged or not? If not charged at the charging system, it's a symptom of CLI spoofing. Again, we saw this kind of CLI manipulation, especially with the MVNO, mobile virtual network operator, that most of the time they rely, for example, on infrastructure of operator A, and they have their own charging system. They usually bring traffic from international, they manipulate it before terminating to another operator. In most of the countries, regulation does not allow transiting call from national operator to another national operator, especially if the call coming from international. So mobile virtual operator are sometimes they are behind this kind of fraud schema. There is another question which is related to the cost of deploying such a system that is able to detect this kind of fraud. So the question was, in underdeveloped country with low infrastructure and technology, what could be quickest and cheapest to detect this fraud? The most straightforward scenario is to do some test call generator. Let's say we target broad countries where diaspora is living and they need to call their family back. So we detect in which country they are living mostly, and we try to generate some test call from this country. It's the straightforward, the easiest way to detect this fraud schema. Otherwise, it's not easy because it's more technical that involve fraudster. That mostly they are at the carrier level, at the operator level, at the virtual operator level. So without having access to the data, access to CDR or signaling, it's not easy. In some country, we saw a kind of level of maturity with the regulator that is trying to make a consumer more aware. So consumer, when they receive a call and they saw a local number that is displayed, it can be a CLI spoofing, SIM-box or something else. And when they answer, they know the one who is calling is someone abroad from the family. So at the end of the call, basically it's a low quality call. So they report to the regulator or to the operator. And because they are aware, they know that they need to report. And with this data, it's helpful for the operator to know and to get some insight from which country this traffic is coming to the local country, and from there the wholesale department can make some moves and try to negotiate better pricing in order to convert gray traffic into legitimate traffic. So at the most of cases, it starts by technical issues, technical analysis and troubleshooting, and getting more insight. But to be able to fix the issue at the source, it's through the whole sales department. It's a marketing, it's a sales issue that they need to make agreement with international carrier, international operator, find where people live abroad, and try to fix the issue with a better offering. Because with a better offering, fraudster will not find an interest in bypassing the price. Yeah. So I agree with the with one of the question from Hiba. Yes, the customer awareness is a better winning solution. So if we educate consumers to better understand the call, for example, when someone is calling me and I see a local number, and then when I initiate the call and I know that the member of my family is living abroad, then I can ask, are you in the country? No, I'm abroad. But why you are using a local number? I don't know. Maybe it goes through fraud schema. So we need to educate consumer to report this kind of behavior. It's very important. And we saw some operators, they provide mobile application to consumer for data crowdsourcing, for quality of service testing, but also for reporting claims. So whenever a consumer see this kind of behavior, they can report more accurate data, like provide the timestamp of the call, the local number, and give some insight also from where the country was originated, and so that give a better insight. That is always better waiting for a real technical solution that can detect and block at scale. Yeah, another question which is related to how CLI spoofing is affecting the revenue if the charge is real time. It is more related to the revenue that the operator earn from interconnection level, not from the amount that the customer will be charged on. So the customer will receive a call. Most of the time it's free. Now, someone is calling from abroad, so it's an incoming international call. So consumer or receiver will not pay that call, of course. But operator that is receiving the call need logically to charge the originator at the interconnection level. So if it's a real incoming international through a legal route, but usually it's an amount per minute, which is sometimes 0.1 to $0.2 a minute. So if the call is bypassed and it become a local or on-net or off-net call, it means that the operator will not receive the termination fee. So it's a revenue leakage. So yeah. I have another question, which is based on the traffic. The regulators can identify the fraud activities, but not the service provider. Accordingly, the fraud call wouldn't stop. How this benefit customer? Let's say there is always a correlation. For example, let's say in international traffic, usually if it comes through legal route, usually it comes through even a SIP trunk or a legacy trunk like TDM. So at each operator, basically they monitor incoming traffic per trunk, and they have the ability to say, like using anomaly detection, they can detect, for example, that something abnormal happened at a specific trunk, and the reason behind can be, for example, a bypass, like a portion of the traffic goes through Simbox, CLI spoofing. And sometimes it's just because one international operator decided to move traffic through another operator instead of the first one, or sometimes simply because there is a quality of service issue on that link. So there is always some symptoms at the trunk level and a specific source of traffic. Let's say operator A in Morocco usually receive 1 million minutes from France. And we know the traffic coming from France can come from SFR, Orange, and so on. And we have the normal behavior during the week, during the weekend, during holidays, and so on, because we have more people living abroad in France. So when a new incoming operator, especially virtual operator in France, they want to move fast, they want to make some specific bundle where people can call to Africa, to Morocco, and so on. So these virtual operator, we need to terminate the call less costly, more cheap. So they will start finding other technique to bypass the legitimate termination fee. So they will never go through a white route. So they will log for Simbox provider, for carrier that manipulates CLI, and so on. So we will see, for example, during a season that there is a drop in the incoming call, but at the same time, we see that there is an increase in the on-net, off-net outgoing call. So this is some symptoms that can help to detect specifically which source that have the issue, and then which service provider originally that sent traffic, and then they can go back to that operator and discuss at the wholesale level what is happening, try to understand why a portion of the traffic is not coming through a legitimate route, and so on. So that's kind of technique that can help to better understand why the source of the traffic is not yet coming from a legal route. I hope that I gave some better answers. So feel free if you have more questions, or We can keep in touch. We can share our email address if you have any other questions, if you want to go more deeply in discussion regarding CLI spoofing fraud or other schema. We are here to help you. Thank you.
I think it's time to close today's session. Thank you all for joining us today for the second episode of the Stop Fraud with Data series. We hope this session was insightful and it gives you valuable insights into how data-powered strategies can help detect and stop CLI spoofing. Just want to remind you to do not miss our next episode. It's gonna be on Wangari fraud and how to stop it also with data. The session gonna be on the 5th of June. You will be directed in a moment after we end our webinar to the registration page. So we encourage you to register to save your spots. I think we reached the end of today's session. And on the behalf of the team of Regulix and Synaptic, thank you again for your time, for your questions, and for your participation. And we look forward to seeing you again. And like Yassine mentioned, if you have questions or you want more information, don't hesitate to contact us. Thank you.